Right, so we've just finished looking at differentiation, and now we're going to have a look at anti-differentiation. And this is just a quick video to go over some basic understanding stuff. Not you won't probably be able to do any questions after this, but I think we need to do this just to see some symbols and different things. So what is this? This weird squiggly thing. So that's the integral or the anti-differentiation sign. All right. Now we had back when we were doing differentiation, we used to use dy by dx, dy by dx, or f dash of x, or y dash, and they all meant differentiate. This here means do the opposite, so anti-differentiate, which we also call integrate, find the integral of. So we call this finding the indefinite integral, anti-differentiation, finding the, I wrote that twice, finding the integral, anti-differentiation, or finding the indefinite integral. So those things all mean the same, and it's all represented by this symbol. And you have to put dx here if you're working with x's, so like x squared or whatever. When we start looking at things like speed again, and we're using t, this will be dt, but just for now, we'll work with the dx. So what is this? Basically, any function that we have, if we find its derivative and it equals f of x, we call the function f, the capital function. We call the capital function the indefinite integral of f of x. So we found the derivative and we've got to f of x. If we find the integral of f of x, we go back to our capital. All right, so it's just one, instead of going one way with our derivatives, we're going back the other way now. So just an example of that, let's call that capital F x squared. So the derivative of that is 2x, all right? So what this means is if we find the integral or the antiderivative of 2x, we go back to x squared. All right, there's going to be some rules, and we're going to have a look at some rules of that, but that's just what it means. If we start with something, find the derivative, this just allows us to go from the derivative back to the starting thing. All right, so a lot of curves have the same derivatives, and in fact, if we've got a function and we add a constant on the end, all of those constants have the same derivatives. And we know that because if we find, like if I say, all right, let's let y equal f of x plus c. If I find the derivative of that, dy by dx, we find the derivative of the first thing, which is f dash of x, and the derivative of the second thing, which is c, so it just goes to 0. So although this c, like for the first one, it could be any number, it could be 4, it could be 12, it could be negative 100, but when we get the derivative, it goes away because it's a constant. So we get this whole, we call them families of functions, and they all have the same derivative, but when we go back from the derivative back, we've got to take that into account. So we had a look and we saw that, you know, the derivative of x squared goes to 2x, and we integrate that goes back to x squared. But we also can see the derivative of x squared plus 4, which is different, x squared plus 4 still goes to 2x. And if we integrate that and we get x squared, doesn't tell us the whole story because we had this extra plus 4. So when we find these indefinite integrals, we have to add plus c. In this case, it's 4, but when we're doing these integrals, every single time that you have something that looks like this, we're going to add plus c, all right? And we can work out what that c is later, but just for now, we're going to add plus c. So the types of functions we're going to be integrating are in the form of x to the power of n, ex, sin x, and cosine x. And we are going to look at some examples of those, and I've made a couple of videos to go with that. So I'm not going to show that in this video, but that's what we're going to be looking at. Just wanted to summarize that. And we're also going to be looking at the same kind of integral, so power of n, except with f of x, all right, where our f of x and e to the power of f of x, sine f of x, cosine f of x are just linear functions, so ax plus b. Again, we'll look at that as we move forward, and I'll give you some examples there. And again, I've written insert examples, but I've done that in the form of a video. If we're integrating two things, what we get is we find that it's the same as the integral of the first thing plus the integral of the second thing. So just a slight useful pieces of knowledge there. So this was just to run through some terms. If you're completely bamboozled, that's okay. We're going to look at some examples now, and that should clear some stuff up. So just wanted to show you some things, and we're going to move on to some videos now. So thank you.